Now, one question I would ask. Now, the question is, can a random walk actually take you, like, can a random walk actually take you away from the origin? Or it might also happen that you are actually, because it is a random walk, like you have seen for the drunkard, he always came back to the origin. Um, will it be the case that there is a possibility or high possibility that this random walk actually hovers around origin? So, can I say that in a random walk, you you're indifferent between these two choices. It can either go far or it can actually hover around the origin. You can think about it. Pause the video and think about it. I'll give 2 seconds, but I'll okay. You can just think about for 2 seconds. Okay, so I'll come back to the this to answering the question. So just think about it. Uh, it's a random walk, right? So you can go far, or you can just randomly go left and come back to right, or go right, come back to left, or anyway like that. So the possibilities are all of these are the possibilities, but which one is that is going to happen? So this is something we'll talk at length later on, but here I'll just give you an example. Okay, so suppose this is the drunkard. Okay, let us have this drunkard at the origin. Okay, it's not really the origin. Okay, this is the origin for the drunkard. Now the drunkard has, suppose this person can actually make a move this way, this way, this way, this way. That is the first move the drunkard takes. Okay, he's equally indifferent. He can go in any of these 4 ways. So suppose he goes to any of these 4 choices. Now what are the other choices he will have? Suppose I'll use a different color. So suppose he's here. Okay, he is here. He is here. He is here. He is here. Okay. So any of these possibilities are there. Now in the next step, the second move he can take, he can go this way, like he had done previously. He can go this way. He can go this way. He can again come back this way. Okay. Similarly, here also he can go this way. He can go this way. He can go that way. He can come back in this way. Here again, he can go this way. He can go that way. He can go that way. He can come back in this way. Okay. For this possibility, he can go this way. He can go that way. He can go that way, and he can come back in this way. So you see, so there are basically when he takes the second step, there are 16 possibilities, and out of the 16 possibilities, 4 would mean that he is coming back to the origin, whereas the 12 others are actually meaning that he will go far from the origin. Now, you can think about more such circles, okay, and you will actually end up having a branching stream of probabilities. Okay, you will have all as many steps as you take, your probabilities will keep on multiplying, and you will see more and more numbers you're actually going away from the origin, whereas coming back to the origin, the possibilities would be pretty low. Okay, so if that is the case, then probably we would say that okay, if there is a random walk, then there's a chance that this man actually would be going a little far from origin than to remain near to the origin. But we will see more that in details. Um, and just to end this lecture, there are 2 specific types of random walk. One is without a drift, and the second one is with a drift. So this part I would recommend you to. This part is not, you know, for this lecture purpose. I would recommend you to look at chapter 13 from, Economic Tricks by Example by Gujarati. It has given pretty nicely about the random walk with a drift and without a drift. Okay,